I'd like to do a couple more problems for you tonight. The first one involves, what I call convenient numbers. It uses the normal distribution, standard deviation. The second problem involves what are called z-scores, when we don't have convenient numbers. You'll see how these two are related and how they are both very powerful techniques. Okay, we have a problem. Craig loves eating, but not catching. He's not a fisher person. The salmon that are caught in Lake Michigan by the fisher people who frequent his Wisconsin sports fishing paradise. Gotta love Door County. 50 years of data show that the fish caught in Sturgeon Bay, that's the city, weigh an average of 15 pounds and vary with a standard deviation of 5 pounds. All right, let's stop there. We got some data. We've got a mean of 15 and a standard deviation of 5. I guess we need to go further though. Assume that these are population statistics and that the distribution of fish caught in Sturgeon Bay is normally distributed. Okay, it said population statistics. So we don't have X bar, we have mu. We have a mean of 15 and we have theta, standard deviation of 5. Okay. If 300 salmon are caught, we are asked, how many would we expect to 1, weigh more than 25 pounds, 2, weigh less than 15 pounds, and 3, weigh less than 20 pounds? All right, let's think about this. Let's draw a picture. I'm going to draw our normal distribution. Ooh, I did pretty good that time. Nah, that wasn't so good. Oh well. Here's our mean at 15. And we know there's these special spots out here. And we know that those special spots, what? Encompass 68% of our data. And where are those spots? They're at plus and minus 1 standard deviation. Well, we know what our standard deviation is, so we can go 1 standard deviation from the mean. That would take us from 15 to 20. That means that's 20 pounds. And we have, let's see if we can go back the other way. There's minus 1 standard deviation at 10 pounds. And let's see, are we going to have to go out further? Yeah, we are. We know there's another one out here. And this, oh, wait a second, let's back up. Between plus and minus 1 standard deviation, we have 68% of the area. That's the area between these two, between plus and minus 1 standard deviation and under the curve. We have another point out here at plus and minus 2 standard deviations. And those points encompass 95% of the area underneath the curve. So let's see, we can add, let's see, easy to add 2 standard deviations to 15, that's 25. And on the other one, we're down to 5. So what are we asked in problem 1? Let's see, we have 300 fish, and we want to know how many weigh more, how many are greater than 25 pounds. So the area under the curve we're looking for is that little spot right there. That's our answer. It doesn't look like it's a very large portion of the area. No, it's not. And that kind of makes sense. If the average fish is 15 pounds, how many are greater than 25? Well, it's not going to be too many. How do we do that? How do we calculate the area in that little funny shaped space? Well, we use this fact right here. We know that 95% of the area under the curve is this spot, all of this in here, all right? So if that's 95%, how much is in that little corner plus this little corner? They're supposed to be the same shape, sorry. Well, if the rest is 95, those two areas have to each be, well, they sum to 5%, and since everything is symmetric in the normal distribution, the bell curve, those each have to be 2.5%. Ah, there's our answer. Quiet, Barney. 2.5%. Shh, is in that little space. There's also 2.5% over in this one, but we don't care about that. We're looking for fish that weigh more than 25 pounds. Okay, so it's 2.5%. Well, simple. Our answer is simply to take our 300 fish, multiply by 2.5%, and what do we get? Let me look at my answer sheet, blah, blah, blah. 7.5. So how many fish is that? Well, you're not going to find half a fish, so let's call it 8 fish. Okay. Do we have time to go on to the next video? Yes, we do. This was number 1. Now we got number 2. Number 2 says, number 2 says 300 fish. How many are less than 15 pounds? Well, again, we draw our bell curve. We say, okay, we know this is 15. Interesting. What do we know about the bell curve? What do we know if we split it by the mean? Don't we know that half of the bell area under the curve falls to the left and half falls to the right? Or there's 50% over here and 50% over here? Yes, that's right. So if we're asked how many fish would we expect to be less than 15 pounds, that's how many would we expect to be less than the mean? It would be half of them. So that was a simple one. We take our 300 fish, multiply by 50%, and we would expect 150 fish to weigh less than 15 pounds. All right, let's move on to our third question. How many would we expect? Sorry. Got to get better lighting in the future, don't I? These flashes are killing me too. Number 3, how many? We got 300 fish. We want to know how many are less than 20 pounds. Once again, we draw our bell curve. It helps me to see what's going on. We got our mean at 15, and let's put our 68% values in, plus 1 standard deviation. Yeah, remember, x bar is 15. Oopsie. Try again. Mu is 15 and theta is 5. So 1 standard deviation takes us up to 20. Subtract 1 takes us down to 10. Question is, how many fish of these 300 we expect to weigh less than 20 pounds? So we're looking for an area under the curve that's less than 20, which is all of that, right? Okay, so what do we know? We know quite a bit here. We know that this area between plus and minus 1 standard deviation is, that area under the curve is 68%. So, let's see, if we just look at, say, that area and that area, the area under both of those is 68%, right? Which means this one's 34%, and on this side, we have 34%. So, let's see, on the right side of the mean, we're going to have a contribution of 34%. What about on the left side of the mean? Do we have 34%? Well, yes, but we have more than that. Since we said we're interested in fish less than 20 pounds, we have the whole left side, which is 50%. So we can add. We have 34% on the right. We add our 50% on the left, and we learn that 84% of the fish are going to weigh less than 20 pounds. And when we take 84% of our 300 fish, we find 84%. It doesn't look too good, does it? 84% of 300, we get 252. 252 of the 300 fish caught, we would expect to weigh less than 20 pounds. This problem, we had what I termed convenient values. They were all exactly, we were all interested in points that are exactly plus or minus 1, 2, or 3 standard deviations away from the mean. Well, that's kind of rare, actually. So in the next problem, we're going to learn about z-scores, in which we don't need to have values that are exactly 1, 2, or 3 standard deviations away from the mean.